Hi class, this is Miss Slater. Just wanted to make a quick video and walk you through how to complete 9.4. That's today's assignment, and it's called the constant of proportionality, or identifying constant of proportionality in both a table and in a graph. So yesterday we talked about how to determine proportionality, and there were two characteristics that we really talked about. Which I'm going to have you write at the top of your page here. And I believe we talked about this earlier this year. But proportional relationships, they have two key characteristics, and these you're going to want to know for your test for sure. The first one is that it goes through or passes through 0, 0, the origin, as well as having a constant rate of change, which is also saying that it is linear. Okay, so those are my two key characteristics of a proportional relationship. So on our first page, we're going to be looking for what they call the constant of proportionality. And this is a fancy word for basically what is the rate of change in this proportional relationship, which we talked about a lot yesterday. And how we can find that rate of change is by looking between my x's and my y's and seeing how, using multiplication, do I multiply from x to y. So here, for all of these, I multiply my x by 10. 3 times 10 gives me 30. 8 times 10 gives me 80. So I'm going to write it like this. Times 10, times 10, times 10. And you can see it here. It's written that every concrete block weighs 10 kilograms. So then if I wanted to write the rule, the equation for this table, it would be written as such: y equals 10x. So whatever that constant of proportionality is, whatever that rate of change that is continual in my table is, that's going to be the same number that is appearing here, as well as my coefficient of x. So if I look at number 1, the number that is being consistently multiplied from x to y is 3. Which means for every can of paint, you would paint 3 houses. And then my equation for that would be y equals 3x. Okay, so pretty straightforward. If, for example, you have some bigger numbers and you're like, I don't know what multiplies to get me from 9 to 342, instead of guessing and checking, what I would recommend is, instead of doing guess and check, you can say 9 times what is 342, aka you can divide these two numbers. You can find the ratio. Remember, yesterday we talked about the ratio of y over x, and for all of these tables, your y is going to be on the bottom, your x is going to be on the top. So if you just go ahead and divide those two numbers, then you will find what the multiplier is. Okay, so that's that first page. That's what you're looking for there. And then when we're looking at a constant of proportionality in a graph, remember, this is my constant rate of change. And when I think back to chapter 4, where we talked a lot about y equals mx plus b, remember that m was my slope and b was my y-intercept. And so here in these proportional relationships, remember, we have a constant rate of change, aka a slope, right? The constant rate of change is telling me it's rising and running by the same thing every time. So these two things are equal. The constant of proportionality is basically asking you what's the slope. And then when I'm taking finding the equation of a proportional relationship, remember our second characteristic is that it's always going to pass through 0, 0. So if I were to make an equation, let's say for the first one, I would first want to find the slope of that line, which I can just go between 2 points. I would just recommend going between your 0, 0 and the first point. So it's rising by 9 and it's running by 3, which means rise over run. I've got 9 over 3. So then my slope, or my constant of proportionality, actually I'm going to abbreviate it like you do in 7th grade. My COP is 3. And then here, the y-intercept, always for a proportional relationship, is going to be 0, 0. Which means that I can say in my equation of y equals mx plus b, the b is always going to be gone. So when it says y equals kx, that's the same thing as y equals mx plus b, where b is 0 and m is the slope. We just use k for constant of proportionality. I wish that it was taught that it was y equals mx, because then that would make this transition a little bit easier for us. But this is saying y equals mx plus b, but b is 0, and m is the same thing as k. Sorry. So for number 1, I'm always going to set it up as y equals, and then whatever I find my slope to be, which is going to be 3, that's going to be my coefficient of x, and then x. And that's it. So, all of these are looking at, do you know what the constant of proportionality is, aka what is the slope of this line, the constant rate of change. And then I would just mention just to be careful about what you're rising and running by, so make sure to look at your graph and how much it's rising by, or how much it's increasing in your x's and y's. But I hope that the rest of this worksheet is pretty simple. Yeah, and we will go over the answers on Friday. Remember that if you finish this worksheet early, awesome, great for you. You still have those IXL fractions. If you have not yet completed those, there's those 5 skills, and those are due on Friday. So make sure you get those done, and make sure to treat Mr. Hughes with respect. And yeah, I will see you all tomorrow.